Section 15.6, surface integral. Start with the first question. Evaluate x minus 2y plus z ds and z equal 3 minus x between 0 and 3, and y between 0 and 2. So here's s, which is equals z equal 3 minus x, and x between from 0 to 3, and y from 0 to 2. Now z sub x is going to be -1, and z sub y equals 0. So the integral for the surface is going to be from 0 to 3, from 0 to 2. We're going to plug in z here. So it's going to be x minus 2y plus 3 minus x, cancel the x with the x, times the square root of zx squared zy squared plus 1 dy dx. So z sub x is -1, z sub y is 0, plus 1. So from here, this is 0, -1 squared is going to be 1, plus 1 is going to be square root of 2. And cancel the x with the x, so it's going to be -2y plus 3 dy dx. Now let's find the integral with respect to the y. This is a constant, take it out. From 0 to 3, from 0 to 2, -2y plus 3. Then the integral with respect to the y is going to be -2y squared divided by 2 plus 3y. Cancel the 2 with the 2. So it's going to be combined. So the left is going to be -y squared plus 3y. So plug in the 2. So it's going to be -2 squared plus 3 times 2 dx. Now it's going to be -4 plus 6. So it's going to be 2 dx. Now 2 dx is going to be 2x from 0 to 3. Plug in the 3. So it's going to be 2 times 3 minus 2 times 0. And the result is going to be 6 square root, because this one is 0. So it's going to be 6 square root of 2. So we're just going to plug in here 6 square root of 2. That's it for the first question. We got it right. With number 2, we're going to do exactly the same thing, but now z equal 15 minus 8x plus 6y, and x between 0 and 1, and y between 0 and 5. So we're going to do exactly the same steps. So here's z 15 minus 8x plus 6y, and x between 0 and 1, and y between 0 and 5. So z sub x is going to be -8, and z sub y is going to be 6. Now the double integral is going to be plug in z here. So it's going to be x minus 3y plus 15 minus 8x plus 6y. So combine the like terms here, and here is going to be square root of z sub x squared and z sub y squared plus 1 dy dx. So combine the like terms here is going to be 15x minus 7x, and y with the y, so it's going to be plus 3y, and -8 squared plus 6 squared plus 1. So here's going to be exactly the same thing. Combine the 64 plus 36 plus 1 is going to be 101 dy dx. This is a constant. Take it out. Then the integral for this one with respect to the y is going to be 15y minus x 7xy plus 3y squared divided by 2 from 0 to 5. Then I plug in the 5. So it's going to be 15 times 5 minus 7x times 5 plus 3, 5 squared divided by 2 minus 0. This is a 0. So 75 minus 35x plus 75 divided by 2 dx. Combine the like terms, which is 75 and 75 over 2. So it's going to be 225 divided by 2 minus 35x. Now we're going to find the integral with respect to the x. So it's going to be 225x over 2 minus 35x squared divided by 2. Plug in the 1. So here's square root of 101. 225 over 2 minus 35 over 2, because we have the same denominator. So it's going to be 190 over 2, and it's going to be 95 square root of 101. So for this, the result is going to be 95 square root of 101. We got it right. Let's move to number 3. So for number 3, it's exactly the same steps, but check here, we have z equal 14, and we have x squared plus y squared less than 1. This is a circle. So let's check how we're going to solve this one. So for number 3, so we have z equal 14, and here is the circle, and the radius equal 1. So z sub r is going to be 0, z sub theta equals 0. So in this case, because we have a circle here, so we're going to convert everything to the polar coordinates. It's easier to work on. Even if you check the z, you have to convert z also and write down z in polar coordinates if there is x and y. But in this case, there is no x and y, so that's why z sub r equals 0 and z sub theta equals 0. But if there is x and y here, you have to convert it to also to the polar coordinates before you're finding z sub r and z sub theta. But for this example, because z equal only a constant, that's why z sub r and z sub theta is going to be 0 and 0. So we're going to plug in here x, which is r cosine theta, minus 2, y, which is r sine theta, plus z equal 14. And z sub r, z sub theta equals 0, 0, so square root of 1. And dy dx is going to be r dr d theta. So from 0 to 2 pi, because it's a circle, so from 0 to 2 pi, and for the radius from 0 to 1, which is dr for the r from 0 to 1, and for theta from 0 to 2 pi, because it's a circle. So for this one, there is an r here, so I'm gonna distribute the r here on the parentheses. So that's why we have r squared cosine theta minus 2r squared sine theta plus 14r. Now let's find the integral with respect to the r. So it will be r cubed over 3 minus 2r cubed over 3 sine theta plus 14r squared over 2. Cancel these, so it's going to be 7r squared. Now 7r squared, let's plug in the numbers. So plug in from 0 to 1, plug in 1, so it's going to be 1/3 cosine theta minus 2/3 sine theta plus 7 times 1 is going to be 7, minus plug in the 0, 0, 0, and 0. So that's why this is here is 0. Now d theta. Now we need to find the integral with respect to the theta. So it's going to be third. The integral for cosine sine. The integral for sine is negative cosine. That's why it's going to be plus here 2/3 cosine theta plus 7 theta from 0 to 2 pi. Now, next step, we're going to plug in. So 2 pi and 2 pi and 2 pi, plug in 0, 0, and 0. This is cancel. This one is 0. This one is 0. So the left is 2/3 cosine 2 pi, which is 1. That means 2/3 times 1 is going to be 2/3, and 7 times 2 pi, 14 pi. And here is negative. This is 1. So 2/3 times negative is going to be negative 2/3. Cancel these. So the result is going to be 14 pi. That's it for example 3. So we're just going to type 14. Got right, 14 pi. Let's check example 4. It's going to be the same steps, but now they ask you to find double integral with f dot product with n ds. We have f with x, y, z, 8 zi minus 3j plus yk, and s is 1 minus x minus y, when they're telling you it's the first octant. So the first thing I'm going to do here is f. I'm going to write down in component form, which is 8z minus 3 and y, and z equal 1 minus x minus y. So on the first octant, so if you let y 0, that means 0 belong to 0, z belong to 0, 1 minus x minus y. Let y equal 0, that means it's going to be y belong to 0 and 1 minus x, and x belongs to 0 and 1. So here's how it looks like the graph. On the first octant, if you graph y equal 1 minus x, and it goes to the z direction, like up. So now let g x, y, z equals z minus g of x, y. That means z minus 1 minus x minus y. So it's going to be z minus 1 plus x plus y. Or if you want to just solve it for z, solve this one for z, that means you're going to move everything here to this side. So it's going to be z minus 1 plus x plus y. It's going to be the same thing. So the gradient for g, if you find the derivative with respect to the x, g sub x is going to be 1, g sub y is going to be 1, and g sub z is going to be 1. So here's the gradient for x, for g. So the double integral f times n ds is going to be the same integral with f times the gradient dA. So it's going to be from 0 to 1 with the x, and for the y is going to be from 0 to 1 minus x, f, which is 8. So here is our f function. So it's going to be 8 times z minus 3 and y. Dot product with 1, 1, 1 dy dx. Then distribute the 8 here. So it's going to be 8 minus 8x minus 8y, and here is negative 3 and y. Do the dot product with 1, 1, 1. So it's going to be this one plus negative 3 plus y. Combine the like terms. So it's going to be 5 minus 8x minus 7y dy dx. Now let's do the integral with respect to the y. So it's going to be 5y minus 8xy squared over 2. Oh, it's 8x, so it's going to be y minus 7, and here is 7y, so it's going to be y squared over 2 from 0 to 1 over 1 minus x. Plug in 1 minus x here, so it's going to be 5, 1 minus x minus 8x, 1 minus x minus 7, 1 minus x squared over 2 minus 0. This is a 0. Now, from this step, I'm going to take 1 minus x as a common, which exists here and here and here. So we're going to get the integral from 1 to 0, from 0 to 1, 1 minus x as a common. So here's the leftover. Distribute 7 over 2 here. So it's going to be 5 minus 8x minus 7 over 2 plus 7 over 2x. Combine the log terms. 5 minus 7 over 2 is going to be 3 over 2. And negative 8 plus 7 over 2 is going to be negative 9 over 2. Now, in this case, we're going to distribute these two parentheses. So it's going to be 3 over 2 minus 9 over 2x minus 3 over 2x plus 9 over 2x squared. Combine the log terms. So it's going to be 12 over 2, which is equal negative 6x. In this case, we can't do anything. Let's do the second integral from 0 to 1, which is 3 over 2x minus 6 x squared over 2 plus 9 over 2 and x cubed over 3 from 0 to 1. Plug in 1, 0 cancel everything. So plug in 1 is going to be 3 over 2 minus 6 over 2 plus 9 over 2. 9 over 6. Simplify this one. It's going to be 3 over 2. That means we can add these together. So this one with this one with this one is going to cancel. So it's going to be 0. So the result for number 4 is going to be 0. We got it right. Let's move to number 6. I'm going to leave number 5 for you. We're going to do exactly the same thing for number 5. Be careful, z here is 1 minus x squared minus y squared, and z greater than or equal 0. So when you convert to the polar coordinates, Be careful here. So let's go to number 6. So find the flux of F across S. So which is F dot product with N, and they're telling you F equal X, Y, and Z, and here's S, which is X squared plus Y squared plus Z squared equal 81 on the first octant. So let's check how we're gonna solve this one. So F, which is X, Y, Z, and here's the surface X squared, Y squared, Z squared equal 81. It's a sphere with a radius 9 on the first octant. So Z, we're going to solve it for Z, is going to be square root of 81 minus X squared minus Y squared. We need just the top half above XY plane. So if you let Z equal 0, so that means everything here equals 0. Take the square both sides. So it's going to be X squared plus Y squared equal 81. That means it's a circle with radius 9. We need just to find the positive one on the top. So solve it for Y is going to be Y equals square root of 81 minus X squared. That means our radius, this is with the Z, we need just the top part. Radius is going to be 9, 9, and the theta is going to be from 0 to pi over 2. So let G of X, Y, Z equals Z minus G of X, which is this one. Sorry, this one. And the grade of G is going to be negative. Let's find the derivative for this one with respect to the X. So it's going to be, with respect to the X, it's going to be negative half 81 minus X squared minus Y squared to the negative half times the derivative for everything inside, which is negative 2X, because we need to find the derivative with respect to the X. And then the derivative for this one with respect to the Y is going to be negative half 81 minus X squared minus Y squared to the negative half times the derivative of everything inside, which is negative 2Y. And the derivative for G with respect to the Z is going to be 1. Now we're just going to simplify this one. This is negative 2 cancel, is going to be positive X divided by, put down this on the bottom under the root. The same thing here, cancel the 2 with the 2 negative times negative positive. So it's going to be positive Y divided by this one and 1. So here is the gain of G of G. Now we're going to convert to the polar coordinates. So we already know X equal R cosine theta and Y equal R sine theta. Dx dy is going to be R dr d theta. So here's going to be R cosine, first of all with the F. So R cosine theta, R sine theta, and Z is going to be equal 81 minus. So what I did here, so we're going to take the negative sign out as a common, so it's going to be X squared plus Y squared, which is equal R. So it's going to be 81 minus R squared. Because you're going to plug in, here is going to be R cosine theta. That means here is negative. And it's going to be R squared cosine squared theta plus R squared sine squared theta. And sine with the cosine is going to be 1. And take the R as a common. So it's going to be just R squared. And here is the minus, so minus R squared. Now, the grade for G is going to be X, which is R cosine theta, over 81, the same thing, minus R squared, and R sine theta, and 81 minus R squared. So this is the first part. Now we're just going to convert the next step, which is going to be, this one is going to be F times the gradient of G, dA. That means going to be dot product. Here is F and here is the gradient of G. r d theta. And here is from 0 to pi over 2 and from 0 to 9. Now let's multiply this one times this one is going to be squared, r squared cosine square theta divided by square root of 81 minus r squared. And r sine theta times r sine theta is going to be squared. Here is supposed to be squared over 81 minus r squared. And this one times 1 is going to be square root of 81 minus r squared, r d theta. Now let's keep going. What I did, we can combine these together because we have the same denominator. And this one plus this one, here is this one, and this one is going to be 1. So the left just r squared, a plus. I'm going to multiply this side by square root of 81 minus r squared divided by square root of 81 minus r squared. So it's going to be on the top, is going to be just 81 minus r squared divided by 81 minus r squared. And now we can combine this one with this one because we have the same denominator. So it's going to be r squared a plus 81 minus r squared. You're going to cancel the r squared. So the left is going to be 81 divided by square root of 81 minus r squared. R d theta. Now this one is easier. Just move the r here. And then we're going to find the integral with respect to the r. But I'm going to let u equal 81 minus r squared. So du is going to be negative 2r dr. Divide both sides by negative 2. So du over negative 2 is going to be r dr. So we're going to plug in everything here. We have r dr. That means this integral is going to be r dr is going to be du over negative 2 and 81 over u, square root over of u. Let's keep going. So here is our new integral. Now it's easier to find the integral. I'm going to take 81 over negative 2 as a outside the integral from 0 to 9, u to the negative 1 over 2, because this is u half, and take it to the top is going to be negative half. So find the integral for this one is going to be u to 1 over 2 divided by 1 over 2 from 0 to 9. That means going to be 81 over negative 2 u to 1 over 2 from 0 to 9. Then bring back the u is going to be 81 minus r squared from 0 to 9. Plug in the 9. So it's going to be 281 minus 9 squared minus 81 minus 0. This is 0. So it's going to be 2 square root of 81 is going to be negative 9 because here is negative and here is 9. So now we're just going to multiply, cancel 2 with the 2. So it's going to be negative, negative, positive. 81 times 9 is going to be 729. Now find the integral with respect to the theta. So it's going to be 729 theta from 0 to pi over 2. Plug in pi over 2 is going to be 729 times pi divided by 2, which is 364.5 pi. So here is the result for the last one. So it's going to be 364.5. Again, we have to find the pi. Here's the pi. That's it. For example, 6. We got it right. That's it for section 15.5.